Well, welcome everybody to the second in our series of educational webinars. We thought that this would be a good time to provide some knowledge transfer while everybody is hopefully staying safe and social distancing and all that kind of stuff. I did mention this before, but these are not sales pitches. This is designed to be educational. And if you see any enthusiasm in my voice about any of these subjects, it's because I'm really passionate about it, especially maturity and things like that, especially how it can benefit the concrete construction industry. Been in the industry about 20 years. I'm on a variety of ACI and STM committees, yada, yada. It's about a 25 to 30-minute webinar. And if you have any questions while this is going on, there's a Ask Questions button down below. Fill out that form, and that actually gets sent as an email, and it'll come directly to me, and I will respond to every single email that gets sent. So without further ado, here we go. Well, this webinar discusses extreme weather concreting, anything from hot and cold weather, and really it's the best practices and the guidance from ACI 305 and 306. Those are the hot weather and cold weather committees, respectively. We're providing tips and tools to help you weather the extremes in concrete construction. I kind of want to patent that. That's actually pretty funny. Anyway, welcome. As I said, I really appreciate you being here, and I hope this is helpful to you. So we're going to get right into it. Basically, what this seminar and webinar is going to cover are the issues that affect concrete durability when you deal with hot and cold weather. So, one of the things that we'll talk about is the effects of extreme weather on the actual concrete itself, how it affects the fresh properties, the curing, the in-place strengths, and of course cylinder strengths, and try to tie all of that together for both cold and hot weather concreting. I'm going to try to identify some of the potential problems that are created during hot and cold conditions, such as the concrete issues that can take place, and also some of the human factors. And then we're going to touch on the mitigation strategies that everyone should be considering, such as planning and being able to share the knowledge that's out there, where the governing bodies have put together a lot of great information for you. So how does cold or hot weather affect durability? So what I did, I tried to break this down into sort of a cold weather side and a hot weather side, because each of these, they're correlated, but they're completely different in how they affect concrete. So for cold weather, I actually put human factors up on top. I think that human factors play probably the largest part in concrete construction. I hear it all the time when I'm out in the field. If it's too cold to pour concrete, it's too cold. That's basically the only time that it's too cold to pour concrete, is when your people can't work outside. We're going to discuss freezing of concrete. Obviously, when you're in cold weather, you don't want your concrete to freeze in a fresh condition. We are going to talk a little bit about how during cold weather you can see and experience very slow setting of that concrete and dramatically slower rate of strength gain. That should be pretty obvious to anybody that's ever worked in concrete. And also the fact that in cold weather we typically have very low humidity, and that leads to a high rate of moisture loss, and that is something that should be protected against at all costs. For hot weather, you have issues that relate more to the beginning stages of your concrete process, such as mixing, transporting, placing, and curing that concrete. These are all things that are really affected by hot weather, much more so than in cold weather. You have the possibility of a lot of cracking. You can get pretty much every type of cracking that there is in concrete, from plastic shrinkage cracking to drying cracking, and also thermal cracking from stresses. So you have to be aware of all of these things. And then because hot weather leads to an increased rate of cement hydration, especially at the early ages, that can counterintuitively lead to lower overall ultimate strengths. you would think that when you have concrete that gains strength faster, that it's going to be higher, and actually it's the exact opposite. So really the whole point is that durable concrete is the goal. Durability is really what we're after. All of these committees, all of the documents, all of the guides that have been written are with an eye towards durability. So a little bit about cold weather. One of the things that the ACI 306 guide tells us to do is you need to protect that young concrete from freezing in a plastic or very young age. That's obviously important. However, and this is going to be surprising to some people, if you have air-entrained concrete, that air-entrained concrete can actually freeze once, as long as it has reached a strength of 500 psi in place. And a lot of people think that that is way too low of a strength for concrete to freeze, but we've done some testing, and that is a good number. As long as you have enough strength that concrete has reached 500 psi, air-entrained concrete can survive that one freeze-thaw cycle. However, you have to, once that concrete thaws out, it has to then reach 3,500 psi prior to the next freeze-thaw event. So in a worst-case situation, if you've got concrete that does freeze early on in its life, you have to make sure that it doesn't freeze a second time. So that's really important. Air entrainment is the key. Most people who are doing cold weather concreting certainly know all about this. There are areas of the country that don't routinely use air entrainment in their concrete, and so they really can't abide by a lot of the guidelines from cold weather because they just don't have air entrainment available to them. And also, I will say this, and it's important, this 306 document cites this repeatedly, but knowing the in-place strength using sensors and concrete maturity testing is really helpful because you'll know exactly what that concrete strength is as it's curing. Now, what about hot weather? For hot weather, one of the things that we can do when, and this is something that's a little bit, again, counterintuitive, when concrete is cured at say a high temperature, 100 degrees, the 28-day strengths will be 10 to 15% lower than if you were to cure that same concrete at a lower standard cured temperature. So high temperatures early on in that concrete's life cycle lead to a lower ultimate strength. Now, this applies to both the in-place concrete and to test cylinders. And so this is the reason why cylinder breaks are so much lower in the summer than they are in other seasons. It's also part of the reason why there are new guidelines about protecting the temperatures of those cylinders in the early ages. There are other high temperature issues that are further compounded with high winds across the surface of that concrete that can lead to an excessive moisture loss. So with cold weather, you can actually experience a higher strength gain due to the slower rate of cement hydration. And this means that you should literally, if you can, take advantage of the lower temperatures to place concrete in cold weather. And this message goes out to all the people who are south of the Mason-Dixon line who essentially stop pouring concrete when it gets to be 40 degrees. To be honest with you, that's the perfect time to pour concrete. You do need to protect the concrete from getting too cold. There's no question about it. There's a line that you have to cross, and the way to do that is you can use a monitoring system that tracks the in-place temperatures, and that's something like our NEXT system, and record the temperatures over time using sensors, and use then, if you can, use maturity to then know what that strength is. For hot weather, concrete can be damaged believe it or not, in any weather due to too much heat. And I'm actually going to talk about this in a little bit as it relates to cold weather at the same time. But concrete, if that concrete gets too hot, it can actually be damaged. And I think that's a point that needs to be made. There are times when it is too hot. Differential thermal stresses can easily cause very bad, undesirable structural cracking. So you should monitor your concrete to avoid this very dangerous situation, especially in any structural applications. So here's I throw this picture up sometimes in, say, September, when it's still nice and warm outside, and I remind people of the cold that is to come in the northern climates, um, and just to let you see some of the extensive measures that people have taken to try to protect that concrete, that fresh concrete, from freezing, just so they can pour the concrete in cold weather. And I just love this picture because I can see all those propane tanks of just sitting there waiting to be either fired up or exchanged out for fresh ones. Again, just another photo of people getting ready to pour some cold concrete. I mean, this is probably cold ground. They're probably pouring 50 or 60 degree concrete in some what look like footers, and it's perfectly fine. It looks like they have blankets ready to go, and they'll be just fine when they place that concrete. The view of the cold weather committee is that concrete does not freeze when the ambient temperature reaches 32 degrees. This is something that I wish everyone, everywhere, would understand. That the concrete doesn't freeze when the temperature reaches 32 degrees outside. There is this old belief that hydration ceases in concrete at 40 degrees, and that is completely and utterly wrong. And I'm talking to you guys, any place near like Atlanta. They literally shut the concrete plants down at 40 degrees. So it's really very conservative, and you can pour concrete at much lower temperatures. And it actually cures very well at low internal temperatures, although it does cure very slowly. So this is a statement straight out of the ACI 306 document, where it basically says to take advantage of the opportunity provided by cold weather to place low temperature concrete, because concrete placed during cold temperatures, protected against freezing and properly cured for a sufficient length of time, has not only the potential to develop a higher ultimate strength, but it does for sure, and also a greater durability than concrete placed at higher temperatures. It is susceptible to less thermal cracking than similar concrete placed at higher temperatures. So this is sort of the back and forth that we have between the hot weather committee and the cold weather committee. Bottom line is that cold weather is better for your concrete. So concrete can be placed at any ambient air temperature, provided that the delivery and the placement temperature of the concrete is adequate to prevent the concrete from falling below what is called the liquidus temperature before protection measures are applied. And that liquidus temperature is just the temperature at which it ceases to become a semi-liquid state into a frozen state. It takes a long time for concrete to actually freeze, mainly due to the fact that you've got cement hydration taking place and it's actually giving off heat. The protection measures should be things like insulating blankets, insulating the forms, and sometimes even just simple poly sheeting, just a simple piece of plastic, will do a lot to keep that concrete from losing too much temperature. Of course, you can always add external heat, and you can even build full enclosures to protect your concrete. Here's a picture of an example of somebody that wanted to make sure that they placed that concrete in whatever temperature it was, and that it didn't get too cold. And I can tell you that concrete covered up that much, as long as it's placed at the proper temperature, so maybe 50 to 60 degrees Fahrenheit, that concrete's going to start taking off in temperature, no matter what the slab thickness is, and it will cure out just fine. And I don't care. It could probably go to 2 below zero Fahrenheit overnight in a situation like that, and it would not be damaged. Here's a great example of where we just did poly sheeting. We literally put poly sheeting on tops of these slabs, and they all cured out just fine, and it was very cold. I want to say it was in the low teens, maybe even upper single digits when this cured out overnight. So it really it can make a huge difference. This was actually a test that we did where in the background, and I'll use my mouse to show you, in the background here we actually had an enclosure that we built specifically to test a slab that or two that were inside that enclosure, along with testing slabs that were just left out with just poly sheeting, and then we had some that had blankets on top of them. So we were looking at all the different variables and and basically what we proved is that concrete cures really well even in cold temperatures, folks. It really does. So this is the viewpoint of, again, the 306 Cold Weather Committee. Monitoring the actual in-place concrete temperatures is really important, not just the surface temperature or the enclosure temperatures. And that means, guys, don't use one of those little IR guns to shoot your concrete temperature and think you're doing the right thing. Because to be honest with you, you can place the sensors down inside the concrete, and that will give you a much greater understanding of the effectiveness of the protections and determining when that protection period can end. The other thing to keep in mind is that moisture loss is a huge issue, because if moisture is allowed to escape from that concrete, you will have a lower rate of hydration, which will mean a lower rate of strength gain, and that's very important to try to prevent that. So a couple of other things. The cold weather, using maturity can certainly help keep external heating operation costs down by knowing the soonest that you can turn down or terminate heating operations, and also deciding when to use external heat or not in the first place, which can save a lot of labor, simply based on the expected ambient conditions. So for example, if you know that the overnight lows are only going to get down to, let's say, 28 degrees Fahrenheit, but you know that by that time your concrete will already be at over 500 psi, or you have plenty of internal heat being built up by the heat of hydration of that concrete, you could possibly decide to not even bother putting blankets on that concrete. And overheating the concrete in cold weather does happen, and monitoring the in-place concrete temperature is the only way to know that. So use sensors, folks. Great example of this was one time I was doing some testing for a parking garage, and it was cold outside. It was in March, but the interior temperature of the parking deck was over 140 degrees. And the reason for that was that the contractor was just pumping tons and tons and tons of heat into the enclosure, and to them, more heat is better, and it's not always the case. And it ended up that they were seeing shrinkage cracks starting to show up, and as soon as they figured out that they were overheating their concrete, then their shrinkage cracks went away. As far as hot weather, there are some of the things that you can do, and this is right out of the 305 document, the ACI 305 hot weather document. You can make sure that the water and the aggregate is cool when you're mixing the concrete. You can use various methods. There's using ice, you can use liquid nitrogen, you can use all sorts of various methods to do that. I encourage you to look at the 305 document for those types of things. You can place the concrete at night or when you know that extreme heat is not expected. You can try to minimize the amount of time spent for the trucks to transport and mix and then place the concrete in hot weather conditions. So plan for that. Plan to make sure that you don't have 4 trucks waiting to offload their concrete in hot weather. Do all you can to protect that young concrete from moisture loss when evaporation rates are high, such as when there's a high wind conditions. And also you can use a ASTM C494 Type D retarding admixture, which can not only delay the set times, but it can also aid with water reduction. Getting back to both cold weather and hot weather committees, they talk about maturity. And maturity is a key to helping contractors and owners too make decisions about when to place that concrete into service and terminate external heating operations. Maturity is referenced repeatedly throughout ACI 306, and I will say this: routine use of maturity is a net benefit for anyone doing cold weather concreting. That is for sure, because you'll always know what that temperature was of that concrete. So here are some of the other things to be aware of, potential problems and this is in terms of human factors. In cold weather, you've got sub-freezing and sub-zero temperatures can certainly cause frostbite and hypothermia. And rapid depletion of energy of these workers in very cold conditions. It's not uncommon for guys to really wear out because your body is trying to generate so much heat. In hot weather, you have rapid dehydration of workers, potential sunstroke and heat stroke, and you need to watch for the warning signs, such as confusion or lack of perspiration of the workers. And really, know when to say when, guys. If it's too hot or too cold, sometimes it is, and it might not be because of the concrete, it might be because of your people. So back again to the big thing, and that is the difference between the in-place concrete and those little test cylinders. So it doesn't matter if these are cured in the hot sun or the super cold. They are going to be affected more by those temperatures than if they are cured, or they're going to be affected by hot and or cold temperatures more than the in-place concrete will itself. So have you seen how these things are cured? Sometimes they're in a cure box, sometimes they're heated, sometimes they're not, sometimes they're sitting off to the side. So the difference between the actual in-place temperature and the cylinders is huge. It really is an issue throughout the entire construction industry and has been for a really long time. Those in-place cylinders, or those cylinders do not necessarily reflect the in-place concrete. This is a classic example where you've got a contractor that put a lot of work into heating up their deck. This was a cold weather job, and here's where the concrete lab put the cylinders. And so if you have a situation like this, those cylinders do not match the in-place concrete. So really, to wrap this up, you've got a couple of situations where you should think about and know what to expect from concrete fresh performance. The things that you need to look for, and this is particularly true of hot weather concreting, is workability, pumpability, the water requirements, and the admixture requirements. This is really important for hot weather concreting. And also you should focus on monitoring the concrete early age properties, such as monitoring the live temperature history using sensors. And also you can monitor the cylinders as well, which would be great for comparisons. And then remember, keep in mind worker performance and limitations. That's sort of a summary statement that the human factors can really play a role in your planning. Put the maturity method to work, and which is ASTM C1074, and you will save money. You will save time, and you will take a lot of the guesswork out of extreme weather concrete. And make sure you have the latest copies of ACI 306, which is the hot weather, and the ACI 305, which is hot weather, 306, which is the cold weather. Make sure you have the latest copies of those guides, and make sure your specifiers have the latest copies of those guides. And the reason I'm saying this is I cannot tell you how many phone calls I get based on people who are reading old copies of these guides. The last time they obtained one was 1976. Please get the latest copies. And I am not trying to sell ACI documents to people. It just makes good sense. Remember, durability is the goal. The durability of that concrete has always been the goal. So again, I want to thank everyone for attending. If you have any questions at all, please send me an email. Thank you so much for your time and your interest. I'm going to put my contact information up there for just a minute. You can also email me directly at john.gnaedinger@concure.com. Anybody that can spell it while looking at it instantly wins the prize. And you can always reach me. That is actually my direct cell phone, 636-675-4800. And come back next week where we have a pretty cool discussion of mass concreting and all of the various issues and things to consider for mass concreting. So again, thank you very much for your time. Thanks for watching, and have a great day.